All right. So yeah, hi. I'm Arun Samuel Baskaran. So I'm basically based out of Bangalore. So this is my first project that I got it completed for the last 3 years. I've been working on. So yeah, the title is Software Defined Snort with Barnyard and Pullpoke for NIDPS. Okay, let me start with a question. How many of you heard about SDN or have you worked with SDN? Anyone? Just a hand wave is fine. Cool. Oh, all right, great. So yeah, so this is one of such product that would be like kind of a defensive mechanism without a manual intervention. Okay, so all right. So yeah, I work with Deloitte as a solution advisor and as a part-time security researcher with UMD and few more community works for the last 3-4 years now. Okay, so SDN and OpenFlow. So SDN in the sense it's like it's nothing but you heard about the management switch, right? A typical management switch. So in case if you are decoupling that particular switch and inserting a kernel level firewall onto that, imagine that is happening. Okay, so that's more like defunding anything whichever is coming via volumetric or application or protocol based attacks. And OpenFlow is along with SDN. OpenFlow is a protocol. This would allow the servers to teach how to send the packets in a network programmable way. So that's the overview. But in a conventional network, each switches in a particular organization or in a particular infrastructure could be modified based on their own dependencies or the requirements, and from that on it could go with the flow. So that's the overview about that. And so I'll give a brief about a few liners about all the technologies that are being used, and then we'll jump into the code parts. Okay, so this next one is Mininet. Mininet and the controllers. So Mininet in the sense it's nothing but a network virtual emulator. So in case if you don't have your management switch in hand to practice in a real time, you can start with Mininet. Mininet's a good start for SDN practices. And controllers, so there are a lot of controllers for means defining the products or means making the rule sets within the switch itself. So here with this particular product, there are a lot of possibilities that we can use multiple controllers that whatever we want. This is completely based on infrastructure security. Okay, and Snort and the dependencies. So this is the one core part, the Snort and the dependency in the sense. This is the integration that I'm doing with the SDN to make sure that the firewall rules and the policies and then the guidelines are customizable and in a high performance way, without manual intervention, and also automatically getting updated along with that. So that's the main purpose of integrating the Snort and other dependencies. And the defenders mechanism, defenders mechanism in the sense we'll be focusing on how to customize your own particular switch based on your requirement or your organizational requirement and everything. And vendors and OEMs controls. So we'll be looking at the offensive approaches, the typical DDoS offensive approaches, and then the ways to secure the particular attacks regardless of the vendors and the OEM. Okay, and finally the end goals and the future possibilities. So yeah, this is the architectural flow. If you haven't heard about management switch, so that's how typically it would look like. The first one would be of application plane, and second one would be of controller plane, and third one would be of data plane. So this is more or like the now now it is in the market, but earlier it was mentioned as management plane, but it came to the application plane as of now. So so this is where we are getting involved as a kernel level security, and also we are integrating Snort and then the dependencies here. And starting from the application plane has means this holds the application logic of what we are about to do, And the network analytics. Network analytics in the sense it could monitor the real-time network traffic within the flows, and also the typical security measures, whatever integrated in the application plane. And these are two interfaces in the sense two agents. The first one is a northbound interface, and second one is southbound, or you can call it as control data plane integrations. Okay. So the usage of this integration, so usage of this agents are to communicate within a particular management switch, so that the data or the transmissible program can be modified based on the requirements. And coming to the control plane holds the responsibility of defining the rule sets for each attacks or the each each package that it is receiving, and with the help of tuples in the sense you might be aware of that, means kind of creating the rule sets right from the beginning, and you could able to utilize those, integrate those into the control plane, so that each packet can be programmable and it can transfer via the packets that whatever it is flowing based on the rule sets. And the next one is data plane. Data plane is the typical forwarding engine for forwarding the packets. However, the control plane instructs to do that. So, okay. So that's the overview about management switch. And coming to the Snort and Barnyard and Pullpoke. So one more question. So like, anybody heard about Barnyard, Pullpoke before? Just a hand view. That's fine. No. Okay. All right. Cool. So Snort is typically known as the network intrusion detection and prevention system, that everyone knows that. And since it's an open source tool, we could able to integrate this with this SDN along with Barnyard and Pullpoke. So Barnyard is another simple technology. It's more or like similar to Snort. Kind of it could be able to integrate the output plugins and the defensive mechanisms whatever Snort is having, but that too with the multi-threading performance. Snort is a single threading performance application, so it can't able to handle large amount of packets in case if there is any. Okay, so that's the reason that I've included Barnyard into that. And Pullpoke is another technology. Means it's a small Perl script. You can use it to automate the Snort rule sets whenever it's getting updated in the public repositories like exploit DBs, CV metrics, or is there any other 0 days are getting published, means it would be automatically updated there. So that's one of the reason that is mentioned as a manual intervention-less product. So that's all about the Snort and its dependencies. And here, if you could come and see, so this one. So this is the admin switch that we are configuring everything right from the SDN. And from that on, in case if you're taking an example flow of two different main switches, so one would be focusing on host-based machines. The other one would be focusing on servers, say for example, ESXi servers or anything else. So this is the flow. So is there any doubts in the architecture? Else we could move forward. So yeah, as I mentioned, SDN, you're going to decouple the plane and then traffic and plan the network traffic, how to perform that. And secondly, the open flow that manages the flow control in the SDN. All right. So Mininet, as I mentioned, it's used to work as a network emulator in case if you're doing it in a virtual way. Controllers, I'm here using floodlight controllers. So there are few controllers you should be aware of when it comes to SDN. One is floodlight, second one is Ryu, third one is open daylight, fourth one is Fox. In case if you're more onto application layer detection protections, means you can always use Fox as a preference one. So that would totally work fine. So here I've used Ryu. I've tried with both Ryu and floodlight as well. So yeah. So Snort, as I mentioned, it's a single threaded platform. So that's the reason that I've included Barnyard to generate the output. And Pullpoke, yeah, it would be frequently updating the Snort rules. So the next one is the defenders mechanism. So here where the core part of the configurations or customizations are getting started. So if you could see the control plane, if you could remember the control plane in the architecture flow, so there are two ways of customizing the control planes. The first one is switch way, and the second one is firewall way. So you can make each switch as a single firewall individually to make it run based on their rules as that what you're giving to them. And third one is the data plane. The first one is divided into two parts. Again, the switch and then the firewall way. And third one is the data plane way. How to customize that? We'll jump into that. So first one, so switch way. Say for example, if you are having if you are maintaining an organization of around 10K people who are frequently using the internet here and there within the intranet itself. So for that, I'm creating a mininet topology with a few servers and then the few switches along with the host machines here and there. And the host machines, that each host machines would be connected with the controller here typically. Okay. So from that on, you have to write the rule sets, whatever it is defined in the control plane. So the rule sets that what we are defining is of 5 tuples here. The first one is source, destination, port, protocol, and then the access to get it allowed or blocked. Okay. And the types of control. So there are 2 types of control for a particular switch in case if you are configuring a switch in the SDN. The first one is hub way. Hub way in the sense it's kind of a direct interaction without any without any flow rules or without any instructions to perform what to do next. So that is kind of a flooded protocol. So this is the worst way of sending a packet or receiving a packet. And even if it is of the switches of controlled or configured in a rule set that this is how to flow means that would typically go in the hub way. So that's the main reason that we have to jump to the second control option. The second control option is learning switch. Learning switch in the sense it's kind of named as a learning switch, but you can define everything within the learning switch itself. So this is the additional part that is being done along with the Snort. This learning switch in the sense you can typically host, say for example, you have divided the network as I mentioned in 2 different parts. The one was the typical lower privilege people who are all, say for example, 5,000 people are low privileged people, and the other 5,000 people are having high clearances for accessing the network. Okay, so imagine if you're having a particular switch, and from that on the 50 hosts or 100 hosts are being there means you have to define each and every firewall rules right from the WAF or right from another infrastructure. For instead of doing that, you can right away configure that particular switch alone, and then you can make it in a possible way to get it reflected within that itself. And in case if say for example as an attacker, even if I'm sitting inside the organization and if I want to flood that network and make it crash or even make that particular switch down in the sense, there is a possibility that it would be blocked right in the beginning itself. Say for example here, I as an attacker, imagine if this is a part of the switch, and before that there is a WAF or any other security product or firewall orchestration suite is there, and I'm sitting inside the organization and I'm sending a packet inside, and in case if it is jumping here and if I'm trying to bypass that particular vendor firewall, and I'll be caught here within the controller, because I as a outsider or insider might not be aware whether the switch is manageable by SDN or not. So here there is another security rules that's defined internally. So along with that, to make sure that the switch is not getting crashed, we are including Snort and then the Barnyard for high performance system. So this is where that second learning switch is coming into picture. So this is where the second type of control learning switch is coming into picture. So from that on, each requests that are being defined in that particular admin host column would be blocked in different ways, whatever you want. Say, for example, you can block it via packet size, and secondly, block it via packet flow, and third one is block it via request per the number of times from the source onwards. Okay. And the ways of learning switch algorithm at each hop. So the next one, the ways of algorithm in the sense, as I mentioned earlier, there might be different sets of people with different privileges. So for that, you have to customize the rules here in the Snort, and here in the SDN, and also there in the Snort. So this, in case if the matches are being there in the particular rule sets right from the attack, in the sense, it would create a alert system, and that alert system would be defining in the it would be stored in the logs, and then the output module would be created. So that's how the flow goes. This is same as the flow for the Snort. So I forgot to include the Snort components, mention the Snort components here. So parallelly, along with the learning switch, this Snort would also be performing in a similar way. Say, for example, the packet decoder. So these are the 5 components of Snort, typical components of Snort. So packet decoder, in the sense, it's responsible for forming the packets in to better use for the rest of the components. And the preprocessors in the sense, it would be defining the particular packet in a sequential way, and to make it perform for to make it ready for the analysis in the next detection engine. And detection engine has the rule sets, and it would be matched against the particular packet, and in case if there is any rules acceptable, means it would be accepting, and it would be sent to the log, and the log would be triggered, and then the output module. In case if the rule is against that particular data, means it would be dropped immediately. So this one would be parallelly happening along with the learning switch. So that's the reason that I told I've mentioned that the way of learning switch algorithm at each hop. So from the first hop to second hop, and in case if it is reaching the end customer, and then if it is going above that, and then coming back to the same path that it is responding, giving back to the server to the client, or the client to the server, means, so by that time you can change the rules. So in case if I'm sending a hi to him, in case if it requires at least 5 to 6 hops and then reaches him, means, and in case if he's saying that hello again, and then if it is coming via the same hop, you can refine the rules it's again in a different way with the same switch itself. So that's the main advantage of using the switch and converting the switch into the firewall, each switches into the firewall. And so this is the switch way, and the firewall way, the same as switch, but there are few additions to that. So it means you can add a rule against the source MAC address, that whether it is getting detected or not. So in case, say for example, if a continuous set of packets are coming per second, and if it is getting say for example, for a given amount of time, for 20 minutes or 30 minutes, or in case if it is happening for more than 2 to 3 hours, means you can block it immediately. That is the reason behind that is you can mark it as the packet is getting by flow. So you can mark it as by flow attack. You can bypass it, detect and stop it. And so that's the advantage of using firewall way. And the hash tables in the sense, you can there is an advantage of storing the keys and then the value pass within the hash table itself, and that has to be done within the switch itself. So there is an advantage of clearing the cache again in the hash tables, and it would automatically make a re-entry whenever it is hitting a server. Means in the flow table, it would get a new re-entry, and then it would be hitting the server and then coming back, and once the packet is done, it would be clearing the cache. So it's kind of managing too many things at a time. And firstly, in case if it is of a huge number of attacks are going on, means there is a performance speed issue that is getting lagged here. So that's the reason that there is another way of doing it. We'll look into the data plane one. So customization data plane. So this is not flexible as software, as you know, because it's more or like it's just doing what the control plane is saying, the data plane, right? So here the speed matters. The speed is the biggest trouble here, because in case if imagine if there was an attack with Google, right, last week. 46 million per second for the last few hours, but they handled it in a very nice way. So that speed matters here. So one typical example is you can use Intel DPDK data plane development kit. So this is one of their programming language that would help to program the data plane in even more faster way and to make it running parallelly in the sense, since it's an internal network, you can do whatever you want. You can open the protocols whatever you need, and based on the opening protocols, you can run each parallel request in each way, and that would make sure that this particular product is not getting stopped or getting queued for a longer requests per second, and that's the reason that it won't be getting crashed. So we can open the parallel lines whenever we want, and that's the main usage of doing this. And with this customization, you have to make sure that we are having a higher performance range with an acceptable speed range as well. So that's the main reason of customizing this control plane. And like I said, Intel DPDK, you can include lot of there are a lot of examples like that. So in case if you would be able to integrate this Intel DPDK into your data plane, means you can even handle millions of attacks per second without having a premium tool or something like that. Yeah. So okay. So I hope most of you are aware of 3 types of DDoS attacks. So could someone point what is volumetric? Bytes per second. Protocol based protocol based is bytes per means a size per second, and application means it's kind of a request per second. So these are the 3 levels, means types of technically describing the DDoS attacks. So in case as I mentioned in the customization of data plane and then the control plane, in case if you are facing volumetric or protocol based attacks, leave the application layer. In case if you are having these 2 types of attacks, means the way that you have customized the control plane, in case if you're doing it in the right way for the control plane with the learning path, you can stop these attacks, these first two attacks. And in the application plane, it's more or like, as we mentioned, the speed matters and then the acceptable criteria matters there. So for that, in case if you could able to customize that with a very good data plane integration for managing the highest speed performance, you can stop the application layer attacks. So mostly volumetric in the sense you can use bots, means attackers, as an attacker you can use bots. Protocol, since it's a network layer 1, can do it, but there is a possibility of getting it hit here and there, but you can miss those things. But for that, we have another solution. I'll let you know that. In the application, you can use POX, as I mentioned earlier in the start of this session. POX is another SDN controller, so you can use POX to, since the reason behind I'm asking you to use POX for the application layer DDoS means it would be having the behavioral and needed resources management there in the POX, and it has that would be communicated via APIs there. So that's the main advantage of using POX. And defensive approaches. So 1 second. So here, there's a typical scenario that I got it in 2 ways. Blocks per second. Packets are blocked by flow. So if you could see here, means I I couldn't able to show this VM since that was done in the VM horizon, so I couldn't able to show you the live. Blocked by flow in the sense, see here, you can track the packets whichever is coming from a same source from the same destination for constantly in a same protocol without any means interruptions, means you can block that by flow. And secondly, in case if the blocks by size in the sense, so here in case if you're facing same types of attack from one part to another part with a higher range, means than the typical packet size range, and constantly if you're getting it from the same source, means you can block it. And as I mentioned earlier, volumetric, they can use bots as well. So you have to predict the unified rules, unified security policies in the sense, there is an advantage of implementing that. The first rule of the first advantage of having a unified security policy is you cannot give a rule saying that you can allow XXX source from XXX destination. So you have to mention each and everything, that where it is coming from and what it is coming from, and those unified security policies should be deleted once from 180 days as a one set and then another set, so that you won't be able to means you won't be using any unwanted features and unwanted application rules under the policies in the unified security policy. So this is more or like means a firewall orchestration suite integration, since we have included unified security policy here, and this is an advantage of using that in this flow. And yeah, that's the overall about OEMs. So this one, when I said regardless of vendors and then the OEMs, so as I mentioned in the earlier stage, whatever, say for example, I'm not going to point out any specific products. Say for example, Barracuda or any other firewall that if you take it as an example. So I, as an outsider, in case if I'm bypassing that based on Barracuda's loophole or Akamai's loophole, and in case if I'm bypassing, I, as an outsider or insider, might not be aware of the kernel level's firewall sitting in the admin switch. So even if I'm bypassing that, I would be caught in another down layer switch as a learning path, learning switch would be giving the security there. So that's the main advantage that I mentioned, that you can block any packets regardless of the vendors or the OEMs completely with the open source tools. Yeah, I hope. AN goals and the future scope. So this is one of a simple product with SDN. So like earlier I was working on another SDN product. So that would be completely DDoS protection without Snort. And I got it integrated with the Snort since there was high performance issues and it couldn't able to handle a lot more packets for defending mechanisms. So that is one thing. And second is manual intervention, without manual interventions. If you could list down the possibilities, you don't need, only thing is you have to configure. The second thing is you don't need to sit for updating the repositories or the vulnerability possibilities that are coming up here. And secondly, even if it is the attacks are getting triggered, you can mention that your unified security policy would take care of those things. And thirdly, each and everything would be logged since we have Snort there. And the fourth thing is like you don't need to worry about whatever types of DDoS are getting involved. So that's manual intervention less one. And DDoS defensive integrations. So DDoS defensive integrations, as you know, most of you, we are struggling for stopping DDoS. Even if we find the very best product, we'll be mentioning it at 99% security. So I go with the same statement. There might be a lot of loopholes here as well. So there might be possibilities, but for that, the only purpose that you will be sitting as an in-person and you will be creating new rule sets in unified security policies, so that same kind of loopholes might not happen again with another organization or an infrastructure one. Okay, so there is another possibility that we can research on. So there is something called You might be heard about NFV as NFV is network functional virtualization. So this is more or like similar to SDN, but the SDN model is completely different, as we could able to program the network data, how to make the traffic go flow in a very different way. So for that, you might be heard about secure change mechanisms in the organizations. So like in case if you're raising a ticket for some kind of issues and you're getting it followed, and the same way in case if you're getting an access to a particular a space or something like that, those kind of secure changes, you can make sure that secure changes are done in a SDN way, so that no ticketing person needs to be sitting in person and doing your analysis and making sure whether it is resolved or the ticket is getting escalated or anything else. So that's one advantage of bringing another one, without manual intervention. So unified security products infrastructure. So there is another product, as I mentioned, the firewall orchestration suites. You can integrate completely with removing the Snort and integrate that with the firewall orchestration suite. So that would make sure that your network application and then the change, everything is going without manual intervention. So that's a future product in case we could be able to do it. And so this input was from this last input was from Nick Feimster. You might be aware of him. He's working with MIT as a professor. So this idea that we got it, I got it via his research. That's it. Thank you. In case if there is any questions, we could discuss. Thank you.
My question is about application layer DDoS attacks, because I've been under the assumption that if we have an application layer DDoS attack, just add the reCAPTCHA v3. If we notice too many requests coming in, just give them a human challenge. So is that not the best solution?
I didn't get you actually.
Like, you have a web application. You suddenly notice a spike in requests, thousands or maybe millions of them. So I was under the assumption that we could just add reCAPTCHA v3 there and challenge them to prove that they're human, that they're not bots. So is that not the best solution?
No, because no, that wasn't the best solution, because two things here. Since you are saying web application as an example, there might be secure protocols or ports that we are also allowing and giving some rules to get the data transmission here and there from the client to server or from the end user. So from that on, there might be loopholes. And secondly, we are depending on a specific vendor. So from that on, there might be loopholes for defining or accepting the security rules and then the policies that are created by the specific vendor. So with that help, there is a possibility of making this web app down itself.
Okay, thank you.
Yeah, thank you. Yeah.
Hey, Arun, first of all, good talk, man. I enjoyed it.
Thank you.
I had a couple of questions in Snort, right? So we're talking from this scalable standpoint. When you spoke about the scalability aspect, right? This is going to handle a lot of traffic. When you see from the preprocessor aspect, right? Are you making any changes from the preprocessor because it's going to handle a different set of traffic? Second thing is the pull poke that you're talking about, right? How frequently are you going to update the rules? Do you have a separate team to sit and write those Snort rules and push it? Because you'll have to look at the control flow, application flow, regex patterns.
Exactly.
Your thoughts on those things?
Yeah. So first of all, preprocessors, yes, you can give your own format for processing that. That would be by bytes or the way that port means the packet is coming, and you can define each packet in different stages, right? For a single TCP packet, you can define it in a frequency way and each way. So you can differentiate those and you can make it in a sequential format based on what your needs are. So that's the best way of doing the pre-processing. And coming to pull to poke, what was it?
I was saying it because it involves a lot of periodic rules pushes, right? And each packet, each attack differentiates itself from regex patterns, control flow. Then you were mentioning about the application, right? Yeah. That involves a little bit of inspection.
Exactly.
Yeah. So how do you handle those things?
So first of all, for that one, you have to sit and you should have a team for dedicatedly means pulling all the public repositories or everything, whatever is possible. You have to do it right from the beginning until today's end, and from that on you don't need much of people's intervention to get it involved, but basically you have to pull it, or you should be having any other any other APIs to contact with the exploit DBs or CV metrics and get it integrated. And along with that, in case if there is any 0 days coming up, means you have to contact that person specifically, get it done. There will be a team to do this, and post that, once it is onto production, you don't need team. Yeah.
Yeah. So first of all, great talk, by the way. Just wanted to explore with you. Have you you mentioned using Snort, and you also mentioned that it is having performance issues, right? So that's why you went ahead and used Barnyard also. So have you considered, again, not to spark a debate between Snort versus Suricata, have you considered using Suricata also along as a substitute to Snort?
No, actually I haven't. So when it comes to IDPS, Snort was in my first mind to get it integrated. I haven't researched on that side, so that's the reason I stick with Snort. And but still, as you mentioned, since it's a single thread mechanism, I got the Barnyard's help to make it even more faster. But in case if there is any, as you mentioned, we can integrate that, and we could reduce the technologies that are being involved, as you mentioned.
So if I understand correctly, so Suricata has multi-threading capabilities also to an extent. So I can substitute Snort with Suricata. You see that as a possibility where you can substitute Snort with Suricata and avoid Barnyard altogether.
Yeah, and what about the pulled poke? Actually, we need pulled poke intervention as well, but pulled poke cannot be included with the Pataria, and we need Snort to get it involved, right? Else, there is another possibility. You have to have a dedicated team, as he mentioned, to get the repositories here and there done without the help of pulled poke. So that would be a kind of a disadvantage. Why I'm saying is, even after in production, imagine if there are a lot of CVs coming in a single month from Microsoft, means you have to assign a particular set of people to make it written exactly in a manual way and then make it run. So that's how it works. In case if that is the way, we can do it, but that would be kind of manual process would be there.
No, but there are scripts that you can write to pull Suricata rules also. So
yeah,
that's where I was just exploring if you can just replace pull poke with an equivalent rule.
Yeah, there might be another possibility. We can get that done. Yeah.
Thank you.
So do you have any resources available publicly if we want to read more about it?
Yeah, I'm going to publish a new video after this one. So I haven't published it yet completely. I'll do it with a PPT as well. As you have seen this SGN short-term scenario. I have to do it. Actually, I haven't publicly disclosed this. I just got it worked a few months before.
Sounds good. Thank you.
Thank you.
Thanks, Arun. Thanks, everyone. A huge round of applause.